In this particular question, you are told that two bodies of 10 kg and 5 kg are connected by a light string. When you are told that two bodies are connected with a light string, it means you are not going to consider the mass of the string. And also another information that is given, we are told that this is a frictionless plane, meaning there is no friction. We are not going to consider the impact of friction on moving object when two bodies are in contact. This is a very easy question when you are told to work out maybe the tension in the string and also to work out the acceleration. So in order to work out this question, it's very, very, very simple and straightforward. What you need to do is to identify and look at these bodies separately. You look at 10 kgs separate and you look at 5 kg separate. Now, in order to do that, I'm going to take you through different steps. One of the things that you need to identify, M1 and M2 are two masses rather, and they have something common. The first thing that they have in common is that they move at the same speed. When they'll be moving at the same speed, and also they'll be accelerating at the same rate. So which means if the acceleration for M1 and M2, if the acceleration of M1 is A, the acceleration of M2 is A. If the speed at which M1 is moving is V, then also the speed of M2 is V. So that's what is common in the two. Now, in order to work out this, we are supposed to find, of course, the acceleration of M2, and also we work out the tension T in the string. Now, in order to work out this, we're going to follow two easy steps. And step one, we're going to consider the 10 kg mass. Now, the 10 kg mass, remember, since it's moving and it's accelerating at the rate of a meter per second, it means now from Newton's second law of motion, acceleration times the mass gives us the force at which that is acting on that particular object. So meaning that our force that is acting on this object is going to be MA, and that is 10 times A, and that because this object is being pulled by the string, so the only force that is acting here is the tension force. So 10 times A will give us the force that is accelerating this object, which is the tension. Remember, there is no friction, so we're going to say 10 times A is the acceleration, equals to the tension of the string. So our tension is 10A, which is our first equation. Now, the second step, we're going to consider the second mass, M2. Now, our M2 here is going to be acted upon by two forces. It will be accelerating downward because the weight will be pulling down, and also tension will be acting upward. So we can be able to work out the resultant force because there are two forces acting and it will be moving downward. So the resultant force will be acting downward. So that will be the weight, which is M2 times the force of gravity minus tension. Remember, this body will be moving down. So the weight is more than the tension. So that's why you can see we are subtracting like that. But this body will be also accelerating at the same rate due to the acceleration A. So meaning that the force also due to acceleration downward will be M2 times A. But we can equate these two so that we have our equation as 5 times G. G does not mean grams actually. It means the force of gravity, the gravitational field strength. So that's why we can now say 5 times G minus T equals to 5 times A. We can rearrange this and substitute what we have here as 9.81 minus T equals to 5A. And our equation can reduce to 49.05 minus T equals to 5A. We can be able to make T the subject of the formula, and then we shall have this as our second equation. Remember, we have two equations now. We can be able to solve equation 1 and equation 2 in order to work out the tension and in order to work out the acceleration. Now, from the first part, remember equation 1 was t equals to 10a. We can be able to substitute 10a in equation 2 and then try to solve for a, divide by 15 both sides. And if we simplify this, we're going to get our answer is 3.27 meter per second square as our acceleration. In order to get tension, we shall substitute what we have as the value of a in equation 1. Remember, equation 1 was t equals to 10a, but already we have obtained a, meaning that we can have our tension as 10 times 3.27, and this is going to be 32.7, and this becomes our final answer for the tension and for the acceleration. That's how you work out this question. And if you have found value in this particular tutorial, more will be coming. Subscribe and give this video a thumbs up. If there's a video you like me to work on also, I'll ask you to leave a comment down below so that I can be able to work it for you.